Okay, so we're on 1-1, day 2. We're going to start with positive and negative. So when we are talking about the positive and negative, it says the graph is positive when all the points are above the x-axis. It's negative when all the points are below. Okay, when I talk about positive values and negative values, I'm talking about the y's. Okay, the y's are positive when it's above the x-axis. The y's are what? Negative when they're below, right? So when we write them as intervals. Sometimes it needs to remind itself where it belongs. You want me to go through it? Okay. Yeah, just leave it on my desk. Thank you. Okay, so it says intervals. We're going to write these in intervals, but I'm going to tell you that intervals are x values. So the positive and negative are the y values, but the intervals we are going to write are going to be made of x values. Okay? This is why when I write domain, I write it in set. I don't write it in interval notation because we use our interval notation on so many other things. Okay? So what we need to do is we need to talk about when the graph is above the x-axis, like from negative infinity to what x value is this graph above the x-axis? -3. It's right here. Okay? See that? So everything over here, the graph is above the x-axis, isn't it?
Yeah.
Okay. Where else is it above the x-axis? From where? From 3 to positive infinity. Yes? And then everything in between is what? It's negative. So how we write that is I get a problem. I'm like, 16, we need to do positive, negative. So I write positive and I write negative. Oops. I don't even know what I'm writing. Okay, so I write positive and negative. Everyone should be able to tell what those two words mean, right? Yep. Okay, so I know it's positive. It starts, what's always over here? It's over here. Negative what?
Infinity.
Negative infinity. And where's this interval stop? -3. Okay, we can never get to negative infinity, so it's always a parenthesis, yes? Now, at -3, that is an x-intercept. Is the y positive or negative or 0 at an x-intercept? It's 0. So that's neither positive or negative. So can it be -3? No. So it's a parenthesis. We're not talking about domain here. We're talking about positive and negative. At an x-intercept, the y is 0. That is not positive or negative, is it? Okay, so when does it start being negative? -3 to what? -3 to +3?
Yeah.
And not included again. I always go left to right because I just jump back and forth and fill them in. And can it go back and forth many times? Yeah, it depends on the graph. Now, when I want to add another piece, I have to add a symbol right here. This symbol means union. It means also. Or means and. Okay? It has to be there. If you do your Math Excel on Monday and you don't put the union there, it's going to count it wrong. Got me? Unless it reads right under, remember under it in blue, it will tell you how to write it or whatever. Unless it says use a comma to separate intervals, they want a U. Okay? So then where's it start back up? 3. And when's it stop being positive? Positive infinity. So the positive and negative are y values, and the intervals are what values? X's.
Is that a U in between?
Yes, that is a U. It is called a union. It means also and. Okay, I want to make sure everybody understands the positive and negative are the y's, but when we write the intervals, we are always using what values? The x values. Positive and negative switch at what part of the graph? Where did it switch at? The x what? Yes, but the x-intercepts? Aren't those the x-intercepts?
Yes.
So they change at an x-intercept. That is the only place this is going to happen. So when you're looking for positive negatives, you go along and look for these x-intercepts. Got it? So why don't you try this one on your own? So write positive and negative.
Yep.
And you're always going to start at negative infinity and always going to stop at positive infinity as if the graph goes forever. When this is like on a calculator, and when it's dropping off of the picture, your assumption is it goes forever. Okay? Now if it stops, you wouldn't start with negative infinity and positive infinity, but this one does. So we're going to start with positive first or negative first on this one?
Negative.
Negative. So from negative infinity to what is it negative?
Negative 5.
Negative 5.
What did I put that for positive?
This down here is negative, yes? It's below the x-axis, right? Okay. Then it's going to go from negative to positive. So negative 5 to what? 5. So this whole section here is positive. And then it comes back down to the negative, so I got to put a u. So it'd be 5 to what? 5 to positive infinity.
Positive.
Because all we're doing is like, imagine like just somebody walking down the x-axis from negative infinity to positive infinity.
I'll be honest.
Then you need to tell me what confused you about that. Because I can't say anything else. I would say exactly the same thing unless you tell me something different. So what confuses you about that?
The whole thing. I haven't got a single thing you said in the past 4 days.
Okay, what about this is confusing you? What does positive mean, Kale?
It's positive.
What does that mean? We're talking about the graph. What does it mean?
Points are above the x-axis.
Okay, so do you see that between negative 5 and 5, all these points are above the x-axis?
Yes.
Okay, so that's that. Okay, so we start at negative infinity because this graph goes off. So I'm clear over here and this graph is clear down here. Okay, we don't have to see it to know that's what happens. So this is negative, correct?
Yes.
Okay, and is this negative?
Yes.
Yes. So from negative infinity to where? What is that point right there?
Negative 5.
Negative 5. It's negative. Then it went positive. And then it's going to come down and go negative. We're at 5 to where?
Infinity.
There you go.
Okay.
That's it. When you guys tell me you're confused, I need you to be more specific, because if you just keep saying I'm confused, I'm going to keep saying it the way I said it. Because there's only so many ways. Okay. So now we are going to go to increasing and decreasing. Before you write anything, what does increasing mean?
Going higher.
Goes up,
Goes up. What does decreasing mean?
goes down.
Goes down. So we are going to talk about a graph from left to right only. Because small numbers are on the left, correct? And large numbers are on the right. So if I come on this graph, I don't want you to write anything, I want you to pay attention. If I'm on this graph up here, and I'm walking across the x-axis, what are the y's doing while I'm coming across the x-axis? I'm going this way, what are my y's doing?
Increasing.
Increasing. See that? Where do they stop increasing?
3.
No. Where do they stop increasing?
2.
On the x-axis, where do they stop increasing?
Oh, at -2.
On the x-axis, 0. Okay? At 0, which is a what of this graph? Isn't that the maximum? So when it gets to the maximum, it stops going up, and it's not going down yet, so it's constant. It's not increasing or decreasing, is it? Okay, now I'm still walking across the x-axis. What is the graph doing now?
Decreasing.
Decreasing. So as I go to negative or positive infinity, the graph is decreasing. Do you see that?
Yeah.
So again, my intervals are x, my increasing, decreasing are y's. So positive, negative happened at x-intercepts, yes? These are going to happen at maxes and minimums. Okay? So a function is increasing when its y values are increasing from what to what? Left to right. Always left to right. A graph is decreasing when its y values are decreasing from what to what? Left to right. You do need to add, so you don't forget, changes from increasing / decreasing at what did we say? At maximums and minimums. See how I did shorthand? If you don't know what this shorthand means, then you need to spell out the words. So it's going to ask you, it's going to give you a graph. The very first graph, if anyone did the first problems, it gave a graph and asked what the domain was, what the range were, what the x-intercepts were, what the y-intercepts were, the increasing, the decreasing, the positive, the negative. I can do all of that on a graph, can't I? That's what they're going to ask. Okay, what I have down here, I just have the equation, I have a table, and I have a picture. That's it. Okay? We're going to look at the table first. Do you see that I have the smallest x value at -3 on the table? Okay? So my x's are getting what? As I go down, my x's are getting bigger, yes? So from -3 or negative infinity, what are the y's doing?
Getting bigger and then getting smaller.
They got bigger, 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 got bigger to where? 0, and then they start getting smaller. Okay? So looking at our picture, as I'm coming across here, I have increasing and decreasing, and it's always what direction? Left to right. So, am I increasing or decreasing first? Increasing. So from negative infinity to what on the x-axis am I increasing? To 0. And these are all parentheses because I'm not talking at the point. I'm talking right, really close to the point, right? So then I go from 0 to what is it decreasing? To positive infinity. Yep. You were making that really hard, weren't you?
I think I'm slow.
I think you were just trying to think it was hard. Okay, am I good?
No.
No? Okay. Sometimes I get talking fast, just gotta slow me down.
I know DK's lost.
Hey, guys, stop. You know what's going on?
He's lying, bro.
I know one was
Hey, guys, I'm recording stuff. Sarah, you good? Not yet? Okay, just let me know when you're. Okay, average rate of change. Do not write anything. Average rate of change. What does that mean?
Ratio.
It's a ratio. Yep. Okay. Well, down at the bottom, I have B minus A, yes? And this is B and this is A. Aren't those X values? Yeah, so that would be like X2 minus X1. Yeah. And on the top, F of B, doesn't that just mean Y? And F of A means Y. What did I just write? Slope. So average rate of change is what? Slope. Okay. So, write on your paper, average rate of change is slope. Write it. And then write M for what? Slope, right? Y2 minus Y1 over X2 minus X1. Now, we use slope on linear lines, correct? Straight lines that are easy. Okay. When you look at this red, I still don't want you writing any of the extra stuff. Average rate of change is slope and slope. Don't write anything else. Because this is the way your book is writing it, and I'm explaining what it says. This red graph, is that linear? No. Is its rate of change constant at all? No. So I can't say it has a slope, because does it have a slope? Actually, it has an infinite number of slopes, and in calculus, we calculate the slope at any given point, but we're not doing that. So what we do is we find an average between 2 points. So we would take these 2 points that are here and draw a line right through them and find its slope and say it's the average rate of change. Now, is the slope of this blue line anywhere close to the slope of that red? No, it is not. But down here, down at the bottom, at A, at that point, the slope is like that, right at that point. Okay? And up at B, the slope is, not writing because my hand's on it, like this. So do you think if I took these two slopes and added them together and divided it by 2, I'd probably get the same slope here? Yeah. And it's much easier just to do the slope. So when it wants average rate of change of something that's not linear, you just take point A and point B and find the slope. That's all you do. That's it. When they say find the average rate of change, they're saying find the what? Slope. So, just a second, let me describe what's here. What's going on here? The directions say find the average rate of change over the interval. Intervals are what values? X's. Well, to do slope, you have to have an X and a Y. So if they give me an X, they gave me -2 and 0, didn't they? Yes? So if I have X's, I have to find Y's. I can look at my graph or I can plug it into my equation, correct? On this one, well, at -2, what's the Y? 1. At 0, what's the Y? 1. Okay, this is a horizontal line. Yes?
Yes.
Does anyone know the slope of every single horizontal line, no matter what horizontal line it is? Nope? Okay, we're going to figure it out right now. Okay, so let's find the slope. M equals, not M, we're not doing slope, we're doing what? Average rate of change. So we write arc. Okay? 1 minus 1 over -2 minus 0. Well, I'm pretty sure that's 0 over -2, which is 0. Okay, so right now, every single horizontal line, I'm just going to tell you right now, the slope is what? 0. No matter what. Okay, now think about it. Slope is rise over run. Yes? Is a horizontal line rising at all? No. So it'd be 0 over any number is still what? 0. Okay, So the next one, what are the x values they give me? 0 and 3. Those are x values because these are intervals. So I could plug it in the equation, but they got fractions, and I don't want to think about fractions. And they also have a picture that I could use, right? Okay, so if I plug in 0, I'm pretty sure I can plug that one in. Plug in 0, I get what? -1? Is that what it says on here? 0, -1? Okay, I plug in 3, and I'm going to look at the graph because 3 times a half, 2 doesn't go to 3 evenly, and that's a whole mess, right? So at 3, what's the answer? 0.5. So now I find the slope. So 0.5. Oh, we don't find the slope. We find the what? Arc. I'm going to keep saying slope so you see those words and you think the same exact thing, okay? So 0.5 minus a -1 over 3 minus 0. So pretty sure that's 1.5 over 3. And I cannot leave a decimal in a fraction, so that's 15 over 30, correct? Which is what?
1/2.
1/2?
Yeah.
Okay. So I'm at 1/2. So its average rate of change between 0 and 3 is what? 1/2. So the first two were linear, weren't they? Could we have counted them if we wanted to? Yeah. Third one, is it linear? Nope. So this one,
You said it was 0.5 minus.
what's 0.5 minus a -1? So minus a -1 would make it positive. Yeah. Okay, so now I want, what are my x values on this one? Better change my color. What are my x values on the last one?
2 and 3.
-2 and 3?
Yes.
So -2 is right here, and 3 is right here. So we're finding the slope of that line, correct? Okay, so -2 what?
4.
4. And guys, -2 squared is what? 4? What's 3 squared? 9. Is that what it is on here?
Yeah.
Yep. So if they don't give you your graph, you just plug it in. And these intervals are always what value? X values. Always, intervals are always X values. Okay, so now we have 9 arc. 9 minus 4 over 3 minus a -2. So 5 over 5 is what? 1. Pretty easy? Okay. Do you now know why I made you do all those worksheets doing slope? Okay. This is a concept summary. It is on page 10. It is the last thing we're doing. I am not going to sit here for a whole long time with the recording going, but you can write down everything. You cannot. We will go through these as we go, but I just wanted to put them up there and let you see. Linear, y equals x. These are all called parent functions. Before you've moved them left, right, change the slope, okay? So these are parent functions. Linear domain is all real numbers, range is all real numbers, and it is increasing from left to right. Do you see that?
Yeah.
Yes. Now, it is negative from less than 0. It is positive greater than 0. If I change the slope, then it would change everything around, right? Okay. X-intercept and y-intercept are both 0, 0. This is a parabola. You have been introduced to parabolas, to square functions a little bit, but now your world is going to be mostly quadratic functions in here all year. Okay, we will do some other ones. So we have all real numbers is my domain. Everything greater than 0 is my range. It's decreasing to 0 and then increasing. It's all positive. But again, can I move this down and left and right and change all that? Yes. This is an absolute value function. We will do all that stuff with it as well. And then we have a constant function, that horizontal line. Now, we talked about this horizontal line. The slope is what? What's the slope of that horizontal line? 0. Because it doesn't rise at all, right? What if I throw a vertical line on there? What's its slope?
Of what? Vertical?
Vertical.
No.
Infinity.
Well, it would be like 6 over running would be 0. Can you divide by 0?
So
Nope.
zero.
So it is
Undetermined.
undefined. Okay? Undetermined. Okay, so it's undefined, and we will do more with that, but I just wanted to put it out there. If you want to put all of this in your notes, it is on page 10. There for you. Oops. But it's a lot. Okay? And I think we are done. Yep.